Welcome back to this AWS TechShift Migrate to Modernize video mini-series. These videos are aimed at independent software vendors who are currently running on-premise and looking to migrate to AWS. It's also aimed at those that are looking to modernize an existing architecture to become more cloud native. In the last video, we introduced AWS Control Tower as our landing zone, and we improved the VPC design by adding more subnets that spanned multiple availability zones. In this video, we are going to look at moving the database away from the EC2 instance and onto a managed service. We will then look at a better way to manage our photos and our static image content by using a content delivery network.
Our photo gallery application allows users to upload, tag, and search for photos. It is a monolithic and everything runs on a single server, including the MySQL database. At the moment, the photo gallery is all running on a single EC2 instance inside one AZ in a public subnet. In the last video, we added private subnets across multiple availability zones. It would be more secure for the database layer to run in one of these private subnets so that it cannot be accessed via public IP on the internet. Moving the database away from the web tier would also allow for the web tier to scale independently, allowing us to add more nodes. To ensure high availability and protect against a loss of an instance or availability zone, we should replicate the database to another availability zone. We can build this new architecture with more EC2 instances. However, we would have to install, configure, and manage the database engine ourselves. To take away this undifferentiated heavy lifting, we will instead use an AWS managed database service. Amazon Aurora is a MySQL and Postgres compatible relational database built for the cloud that combines the performance and availability of traditional enterprise databases with the simplicity and cost effectiveness of open source databases. What benefits do you get from using Amazon Aurora? It's fully managed, so there's no servers to provision, software to patch, no setup, no configurations or backups to manage. It's fault tolerant, it's self-healing, and you get 6 copies of data across 3 availability zones, as well as continuous backups to Amazon S3. It's highly secure, there's network isolation, you can provide encryption at rest and in transit, and it complies with a number of compliance and insurance programs. Performance and scalability, there's 5 times the throughput of standard MySQL and 3 times the throughput of standard Postgres. You can also scale out by adding up to 15 read replicas. One of the key features of Amazon Aurora is the separation of storage and compute. When you create an Aurora cluster, it creates a storage volume that is automatically replicated across multiple availability zones. This means when data is written to the primary database instance, Aurora synchronously replicates the data to 6 storage nodes across those availability zones. This provides redundancy and protects against failures. Compute nodes can be added or removed from the storage volume as required. We can easily migrate the existing MySQL database to Amazon Aurora MySQL and change the connection string within our application server without other code changes. We now have a database in a private subnet with data replicated across multiple availability zones. We can also scale out the web tier independently. Now let's focus on users accessing content from the web tier. Currently, photos are stored and served by the EC2 instance. This is okay, but if we need to add more instances to scale the application, we need to ensure the photos are accessible by all servers through some form of shared storage or replicated storage. We also need to ensure that photos are protected from the loss of a single instance or an availability zone. Amazon Simple Storage Service, or S3, is an ideal place for storing and serving the photo gallery images. S3 provides 11 nines of durability, and objects are automatically replicated across multiple availability zones. Storage capacity is virtually unlimited, as well as being cost effective, allowing the volume of the images to grow with usage increases over time. Amazon S3 can be accessed via HTTP requests, meaning the application code can be tweaked to point image upload and download requests directly to S3, reducing the demand on the EC2 web server and improving scalability. We're going to make one final improvement to the architecture in this video, and that's to introduce a caching layer. Currently, the photo application is running in an AWS region. AWS has regions across the world. However, users may not be geographically close to the serving region. This can introduce latency and is not optimal for user experience. In addition to regions, AWS has hundreds of points of presence, edge locations, in 90+ cities across the world. Amazon CloudFront is a web service that speeds up the distribution of your static and dynamic web content, such as HTML, CSS, JavaScript, and image files to the users. CloudFront delivers content through these edge locations, which are often much closer to your end users, reducing the latency and improving the application performance. Back to our architecture diagram, let's add in the Amazon CloudFront Content Delivery Network. Now end users will be directed to CloudFront. If content such as images is already in the edge location, it will be served to the end users with the lowest latency. This will also reduce the requests to the EC2 instance and the S3 bucket, helping improve scalability and performance. Join us in the next video where we'll look at automatically scaling the EC2 instances and defining the AWS infrastructure resources as code.